So what I have here and what you should have as you get logged in is I've just got one of these new VMs. They're different than the ones from yesterday, so they won't have anything that you or anyone else did in them yesterday. And then on the other side, I've got the configuration tutorial. And to start with, we're just going to focus on this bit at the top, which is the instructions to kind of catch back up if we're picking things up in the middle, which we all are, given the break overnight. So once you've logged in, you're going to want to git clone. We're going to use depth 2 just to save some time. And we're going to clone from the branch releases v1.0. It's the same as yesterday. https://github.com spack.git. And then we're going to source the Spack setup script, just like Kathleen showed us how to do yesterday. And we're going to do a Spack repo update built in to the tag v2025.07.0, and that's the tag that was released in conjunction with Spack's 1.0 release. Then the last two things we're going to do is we're going to do a Spack mirror add, and we're going to do it a little differently than yesterday. We're going to add the -- unsigned flag, and that's just saying that, you know, for today, in a toy environment that we're going to tear down at the end of the tutorial, we're not going to worry about signing the binaries. And we're doing this because we had a little DevOps mishap with setting up the cache. And it's in /mirror, just like it was yesterday. And the last thing we'll do to get set up is we're going to Spack compiler find. And that's just going to tell Spack to search out any compilers that it can find in the path. And we'll find the same 3 compilers that we were dealing with yesterday. That's the LLVM 14, and GCC 10.5.0, and GCC 11.4.0. And conveniently, while it's out spidering my path, we'll have a moment to kind of make sure that everyone's on the same page. And make sure that everyone's set up before Peter takes off with the rest of the configuration section. I saw a question about this. There are no slides whatsoever for the presentation today, so there are no new slides. Everything for today is going to be the hands-on from spacktutorial.readthedocs.io, which Alec and Tammy have put the link to the configuration section and to the overall page in the chat. And then using the VMs from the link that I put in the chat, and I'll put that in again if anyone needs it. But assuming people are mostly caught back up, I'm going to stop sharing my screen and turn things over to Peter.
If things are good, you'll see the tutorial page on one side, terminal on the other. Thanks, Greg, for doing the setup. We won't have we won't have any of the extra config that we added, but we can sanity check using the commands that we covered yesterday, at the end of yesterday, to make sure we have what we're looking for. We have, so we see like at a high level, um, you can configure lots of things about Spack. It's divided into a few high-level categories. Um, it's in all cases it's expressed in a YAML format, and it almost uh, conforms entirely to YAML, with one exception where we use a double colon syntax for overrides. I'm not going to recover that, but that is covered as part of this tutorial. And um, the then you can define the same category in different areas, and Spack has a prioritization for that. And our blame also shows that we have the default scope, we have the user scope. That's what we implicitly modified when you ran Spack compiler find, and we have our 3 compilers, and we showed some examples of modifying those compiler entries to add flags, and we didn't we didn't do this hands-on, but we also covered like other properties that you could set on compilers to affect Spack behavior. And then we got a little bit more into um, uh, setting preferences and requirements to guide Spack's concretizer. So we're going to get back into that, and that's actually most of the tutorial, so we don't have too much left to do. Um, so we're just going to recreate uh, an environment. You can call it anything. Um, Now, and this is interesting. One command that we did run at the beginning, we're going to want to rerun. And in yesterday's case, we did it to the uh, the user scope, and in this case, we activated an environment, and that's actually going to become our default write scope, and we can see that uh, in action here. So we can do Spack. You can look at your environment by providing. Oh, whoops! I forgot to act. Okay, apparently I didn't do exactly what I just said because I forgot to activate my environment. If you did activate your environment because you remembered Gaetano's presentation yesterday, then you're going to be doing something good. Um, Anyways, so this is exactly like yesterday for me. You know what? To Because we're going to have to undo that reuse thing at the end, and because I gave bad instructions, I'm going to cover a couple of things. Let's see. Oops. What did I do wrong here? Oh, whoops, I forgot to say edit. So I just want to edit. I just modified the concretizer scope, then I activated the environment. Um, so this is what I did, because I did it outside of the environment. I did it, you can see at the bottom, I'm editing my user scope. So there's a few things you can do. I'm just turning this into an empty configuration. You don't have to do this, we can cover it at the end. But I'm going to re-add this to the environment scope. I think this was covered in Caetano's presentation yesterday, but you can see what environment you have active. It'll be like bold. I only have one environment right now, but the other environments would just be listed in plain text. Um, so at this point, you can modify you, you can modify the user scope, undo the reuse setting. I'm going to reapply the reuse setting into the uh, environment scope. So now we have reuse off. Okay. I think that was a little jumbled. If anyone has any questions about that, please ask. But there's a few, uh, yeah, if people are asking about like, why is the environment empty or something, all the VMs are starting from scratch. Um, so at this point, uh, ideally your environment looks like this, specifically with the reuse off. And if I don't see any, if I'm happy to return to that because I went about it in a fairly jumbled way. apologies for that, but otherwise I'm going to think everyone managed with that. So anyways, we have reuse off. We messed with our compilers and we started looking at how we could affect our HDF5 concretization. Our sort of vanilla HDF5 concretization preferred GCC and OpenMPI. Oh, looks like first time setup. But we will want to add some of this back. We went through how to essentially tell the Spack concretizer that we want to use Clang generally instead, and that when we concretize MPI, it has to be MPitch. And in specifically thinking about HDF5, it's like, oh, well, on the other hand, it's kind of a fair amount of work to build MPI. So for now, we're going to turn it off. Anyways, let's looking at the vanilla concretization. We have GCC. We have OpenMPI. So we're going to reconstruct most of this environment, but we're going to imagine that we're back. We're going to want to build HDF5 with MPI again. So we're going to partially reconstruct this. So you can Spack config edit with your active environment. And we're going to start by reapplying the LLVM preference. There's a way. So like I said, this is telling Spack like you want it, but you don't need it. There's ways to tell Spack it has to be that. And there's more in the configuration docs about that. Not sure what that was about. Oops. Whoops. Okay, sorry. Forgot. Don't want to apply this one. We want to apply the MPI one. We are going to re-add curl just because it's actually like pretty easy to do. So, and I think I mentioned that there's a not buildable option. So I think we're going to try that here. Just got to spell it right. So if we look at that, we have automatically added the part that we added manually yesterday. We have a new curl. If we reconcretize, we will see that Spack is no longer going to try to build curl itself, which is kind of nice. We imagine we don't need anything special from curl. So we went through that. And so a lot of times when you're using MPI, you already have one on your system. That's usually the one you want to use. Spack can definitely build MPI implementations for you. But we are, in this case, going to say, we're going to look for one and add that as an external. Look at our environment. We have an external. Oh, interesting. That was unexpected. The important thing in the config here is that we marked MPI itself, the virtual, as not buildable. This won't cause any problems, but it doesn't do much buildable on the implementation. All right. So at this point, we're right back up to where we were yesterday. We've seen we've gone through a couple of concretizations. And now we've sort of like over time added more and more, and we're going to see that at this point, we've actually added too many constraints because it turns out like the M pitch that we found is going to be incompatible. Set this up. So if you run Spack HDF5, we're not going to see an NPI choice. And then we're going to force the point just below. Are there a lot of questions? Like something that might be worth, I'm seeing a lot of chat. Is there something that I should perhaps,
People are asking you to leave things on the screen a little bit longer.
okay, sorry. I will go back to the configuration after this concretization completes. So it'll be a little backwards. We'll see the result and then I'll show you what got the result. So anyways, at a high level, we asked for, we thought we were going about setting up an MPI for us to use, but then we asked for HDF5 and now we're not getting it. So going back, because this is another, I mean, I certainly do this to myself in Spack where I add too many constraints and then it tries to help me out. But here's the config we're working with. We have uh, a curl external. This entry here is not critical to this example, but you can get it very quickly by running Spack external find curl. This we added manually, and that's not essential. You'll get GCC in your concretizations instead if you don't set that. For this outcome, you will need this individual mpitch bit and the MPI config. I'm just gonna delete this because it's not essential. If you run Spack external find not buildable, you'll get that entry. But just to sort of show you what's important to this example, it's going to be this. We set MPI to be not buildable. An important thing is that that's at the virtual level. So mpitch is an implementation. I think yesterday we covered like the notion or the difference between like a API like MPI and the implementations of it. So this is basically telling Spack like you can't satisfy MPI whenever someone requests it by introducing some other new um, implementation of MPI. One that comes up in Spack, like one you might see in Spack if you become too constrained in your MPI without doing something like this. There's actually a Spack implementation. There's an MPI implementation in Spack called MPI Lander. We semi-frequently get people asking about that. So anyhow, I'm not seeing the chat there seems to be fewer messages in the chat. So let me know. Feel free anyone to do that. And at the end, I'm sorry to have created like thanks for going over adding the reuse bit. You can add this manually if you want while we're in the middle of it. I'm going to deactivate the environment. If you did what I did and you ran this outside of the environment, but didn't follow the part where I removed it outside of the environment, I'm going to re-execute that at the end of this tutorial. So I'm going to make sure there's no vestigial bits. So anyhow, we added all this MPI stuff hoping that we could add our MPI implementation to HDF5, but we didn't get it. See, so we're going to, like I said, we're going to try to force the point. Say like, well, it'd be nice if we actually got MPI now. The looking a little bit ahead, we're going to see that there were basically too many constraints. The MPI implementation we added is actually incompatible with HDF5. So we just cannot, so the concretizer is going to basically tell us you can't you can't use or enable MPI support because there's no basically viable MPI implementation to be used with HDF5. So that's kind of getting to the end of, I think, pretty much all the hands-on stuff. We have a few more examples of things you can set, and I'll go over those pretty quickly. You can set package permissions. So we imagine having a package called Converge. You can set permissions for that specifically. So when you install it, you can set, like if you have a shared Spack implementation, but you want to control permissions on like a per install basis, you can set them in your configuration so that Spack basically respects that, and only only the groups you want have, like, say, the accesses you want. Okay. We can deactivate the environment. You'll want that deactivated for future sections. I think we talked about high level config. This is where you can influence things like where Spack installs packages. You can customize the layout of the package installs. This is, yeah, you can, Spack tries to always do your installations into temp space to make things faster. That is not necessarily long-lived though. So like, if you're doing a Spack installation inside of an allocation on a cluster and uh, you want you want like temporary build files to live longer than the allocation, you might want to assign a stage directory into a persistent area. So this can be of interest to folks doing builds in allocations. There are many settings in here. We used aliases as like a example of overrides yesterday, and that's touched on at the beginning of the tutorial. Yeah, I think I was just covering this. You may want to point your build stage somewhere. Think, uh, oh, okay. Config is also where you set build parallelism. I forgot that actually. So you can, if you don't set this, I actually don't know what the default is, but we can see it with Spack config, blame config. Well, actually, my terminal makes that, my terminal scrunching makes that a bit difficult to see. Um, let me specifically look for it. Oh, 16. Okay, so the default 16. You can set it lower or higher if you want. And then I think the tutorial points out you can also set it to 1. You'll get serial behavior, and you also won't mess with anything. All right. Actually, this is interesting. Let me try. So at this point, we've deactivated the environment. Not sure what happens if I remove this when. Okay, I was happy to do it. So at this point, though, it should either have no effect or you should end up with you basically end up with an empty looking concretizer section. So you've deactivated the environment, you run this command, you run and you run, you can finally inspect that by running spack config edit concretizer. We look at the scope that we would have modified if you would run it outside the environment. And as long as that looks clean, you'll be good for future sections. So that is the conclusion of the config tutorial. There's more in the docs for config. If anyone has any questions there, let me know. But otherwise, we're good. I see a question. Can someone elaborate on what the concretizer is saying? I can't say Can't quite see where the non-satisfiability is popping up. Um, oh, sorry. That
So
was already answered. Sorry, Greg.
yeah, and if the answer is like what about it is causing the non-satisfiability, the constraints from the HDF5 package itself are conflicting with the MPI that we told it had to use. So that's why it's saying, no, that's not a possible combination. Um, in the interest of time, I'm going to refer the rest of the config questions to the chat
Okay.
and move forward with the Spack stacks section. So we've got the setup here at the top of every section. So if you have just joined us and just got an image, you'll do this to catch up with how we got set up. But I'll move on to talk about Spack stacks. So Spack stacks as a name is kind of left over for when we thought this would be a different or more different than environments. But fundamentally what we're talking about here is an environment with combinatorial complexity. That is, I'm not just installing one set of software for myself to use. I'm installing the same software with a variety of tool chains, variety of compilers, variety of MPIs, whatever exactly it is, to then deploy to a group that will take advantage of that breadth, whether that's as a facilities staff setting up a supercomputer or like the build engineer for a team setting things up for their team. So what we're going to do is first we're going to focus on how to configure Spack to install what we want, and then we'll talk about how to make it easy for the users to navigate that software without the users needing to understand Spack themselves. Before we do that, however, I am going to set my editor because otherwise you will have to watch me flail around in VI. All right, so the first thing we're going to do is we're going to set up kind of a base compiler for our software stack. And there are two ways that we can do this. One is we can install the compiler first and then install the rest of the environment. So our environment is kind of a multi-stage process. The other is to install the compiler somewhere outside of the environment in another environment on its own, and then use our environment, just kind of assuming that compiler exists already. We'll do the first option today. So the first thing we're going to do is create an environment, Spack env activate -- create. And we're going to do a standalone environment in our home directory /stacks. And that is what you will see if you forget to source the Spack setup script before you run Spack. Okay, there's my environment. We can see that I'm in that environment. And I'm going to Spack add GCC at 12, built with GCC at 11. GCC at 11 is the system compiler that I know is available here, and GCC at 12 is what I want to build with. Now I'm going to Spack env view disable. This is just going to turn off the view for this environment for now, and we'll come back to it later on in this section. And if I do a config edit, we can see what we have here. I've added one spec, and we've turned off the view. So let's concretize and install this environment. I will start talking a little bit ahead as we wait for this to run, but I'm going to try not to get too far ahead. So the next thing we're going to do as soon as this environment concretizes and installs is we're going to add two different specs for the same package into this environment. And if we do that and we just try to concretize right away, we're going to get an error message. Because we have unify true set in our environment. And unification in Spack is a little bit tricky. We've got a diagram here in the script. If you imagine our environment, we've got our two versions of netlib scalapack that we're about to add, and one version of GCC. And they've got a variety of link and run dependencies, and then they've got their pure build dependencies. And when unify is true, everything in this red dotted circle has to have only one name per, or one package name, one spec per package name. We can relax that to unify false, which just says concretize everything separately as if it was all in its own environment. Or unify when possible, which says within the red circle, limit the amount of duplication as much as possible, but you can duplicate things if you absolutely have to. We're going to go with unify false. Unify when possible is generally for environments with very little difference, whereas our environment's going to be different, kind of incompatible across the board. All right, so our GCC has just finished installing, or at least mine has. And I'm going to say Spack add netlib scalapack built with GCC 12 with OpenBLAS and OpenMPI. And I'm going to do the same thing with OpenBLAS and MPitch. And now I'm going to say Spack config add concretizer unify false. This is what we were just talking about. And now I'm going to concretize the environment again. And with unify false, Spack will parallelize the concretization. So in this case, it'll go up to 16 concretizations at once, but with only 2 specs, it can't go wider than 2. And to some extent, this is enough. We could, at this point, just start building up our environment and add more and more specs this way. And we'd have a big, long list of specs in our environment. And that's not really the best way to manage things. So if we do a Spack config edit again and bring back up our environment, I could keep listing specs here all day, but I would rather set up a spec matrix. And this is going to effectively be the cross product of some lists of specs. So I can say netlib scalapack. I've only got one top level spec here. I want it built with both OpenMPI and MPitch. And I want it to be both built with OpenBLAS and netlib libpack. And this is saying every combination of these options. And I want it to be built with GCC 12. And for the GCC spec, we have to put it in quotes because YAML doesn't like strings that start with %. So this is kind of a toy example, right? It's 4 lines and it's only describing 4 specs, but hopefully you can see that as these lists become longer, it's really saving us a lot of space to write this more concisely. So I'm going to save that and I'm going to run Spack concretize again. And 2 of the specs are the same as the ones that we already concretized. So we don't need to concretize those two, and the other two will concretize now. And this time, once it concretizes, we'll also install this environment so that we have the actual installations around later when we start talking about how to expose this to users. So we're going to Spack install, and that should go by reasonably quickly. But it is quite a few things that are getting installed. We can see in the Spack find output in the script just about what we should be expecting to install. So once that all works, and we'll run Spack find to verify that we got what we wanted, we're going to keep focusing on how we can improve this further. So the next thing that we're going to do is we're going to refactor the exact same environment to use named spec lists with the eventual end goal that we might want to use our list of compilers or our list of MPIs in multiple places, right? We might want, here's our packages that build with MPI and LAPACK and a compiler, and here's the ones that build with MPI and LAPACK, and we don't want to have to list the same thing multiple times. So we're going to want some variables. So Spack config edit. These variables we write into a definitions section. So definitions, we're going to define our MPIs as OpenMPI and MPitch. We're going to define our LAPACKs as OpenBLAS and netlib LAPACK. We're going to define our compilers as the list containing just our one compiler, GCC at 12, and our MPI packages. Excuse me. Netlib Scalapack is the only one we're using. And then we can come down into our matrix, and we can put in our MPI packages, and we want the cross product of that with all of our MPIs. And we're going to use this syntax for both MPIs and LAPACKs. That means expand the list, but treat the specs in it as dependency constraints. So that takes our list that's just the names, OpenMPI and MPitch, and turns it into caret OpenMPI and caret MPitch, expressing dependencies. And then we're going to do the same thing here, but with a direct dependency for the compiler. On all one of our compilers. And if we do this, we haven't changed the environment at all. Nothing new to concretize. I promised a Spack find earlier, but I forgot to do it. Here it is now. Here's everything that we've installed as part of this environment. And we can see our 4 netlib Scalapacks for the cross product of our 2 MPIs and our 2 BLAS implementations. Now we can start reusing these definitions. As I started to mention earlier, we can say, maybe we have some serial packages. Like PySciPy needs a BLAS implementation, but it doesn't need an MPI implementation. And so then we can add another matrix. And It's to build our serial packages. And for this matrix, we will use our LAPACs. Sorry, it needs a LAPAC implementation in addition to a BLAS implementation. We'll use our LAPACs, but not our MPIs. And of course, we'll still use our compilers. Now, the other thing we can do with a matrix is we can exclude something. So we can say exclude anything from this that satisfies the spec netlib LAPAC. And you might notice this is a very, very toy problem. We have just used this entire matrix syntax to effectively define one spec because we've put two specs for SciPy and excluded one of them. But hopefully this will show you how the mechanism works. So this is straightforward. We can concretize our environment again. It has one new that's going to concretize two things, which means that I must have typoed in the exclude spec. So I'm going to kill that. Spack config edit again. And indeed, I did typo in the exclude spec. And I'll concretize. And once that's done concretizing, I'll install. Okay. Let me open the chat and see about questions. So when we're editing the config, if we change the root specs of the environment, Spack will recognize that and it will remove any root specs that were removed from the environment, remove the specs associated with any root that was removed from the environment, and concretize any new root specs that are new to the environment. And a change is just a removal and an addition. For that, we don't need to do a force concretize. But when we change the config in a way that is going to change how the same root spec will be concretized, that's when we need to do a force concretization. So hopefully that helps, Byron. And we'll install our environment now that the concretization has finished. And most of it, or many of the packages it needed were already there from dependencies of the other things we've installed. But a few of them are needing to be installed now. And we will finish up with Python or with PySciPy just about now. So we can do a spack find -ld PySciPy, and we'll see that this is the one, of course, as we would expect, built with OpenBLAS. If I can track down where OpenBLAS is, there it is. So the last thing we'll talk about for constructing the list of specs is conditional definitions. So what if we want some conditional definitions for which MPIs we use when? Maybe we'll use certain MPIs on certain systems or in certain environments. For our case, just for the demo, we're going to say we always want mpitch, and we also want OpenMPI when, and here we're going to just write some Python code for the conditional. env.get spack stack use OpenMPI. There's the default, so the getter doesn't fail, equals the string 1. And I need to change my outer quotes to not mess with my inner quotes. Okay. So what are we looking at here? So first, what are the conditionals we can use? We can use the platform, the operating system, the target, the architecture, which is the tuple of all three. We can use this env dictionary, which, if you're familiar with Python, this is just os.environ, right? This is just the user environment. You have access to the Python regex module RE, and you have the host name of the node. And those are the only variables you can use. And you write any valid Python single liner, and that will be evaluated to check whether to satisfy this conditional. It's important to note that the target, platform, etc., are the platform of the system and the default target of the system, not the target of the spec, because we don't know what specs we're dealing with yet at this point. Now, the other interesting thing about this is if you define the same name multiple times, the entries will be concatenated. And that's what allows you to do conditionals that might have some unconditional components and some conditional components. Omar mentioned that on different architectures, packages sometimes are named differently. That is true for some package managers, but is not true for Spack. The package names are always the same in Spack, regardless of the architecture. So we're going to concretize this now. And it's going to return really quickly. There's nothing new to concretize. But if we look at it with Spack find, we can see we took away 2 of our netlib scalapack options or specs because they depended on OpenMPI, and we haven't set that environment variable. And now for our toy example, it's really easy. We can export Spack stack use OpenMPI equals 1 and concretize again. And we're going to get those same 2 specs right back because we didn't change anything about how they'd be concretized. Only whether they're present or not. Omar, different distros can have different names for the package, but the distro name is not relevant to what the name for it is in Spack. So if you're trying to install it as an external, you might need to know the distro name to use the distro to install it. But then from Spack's perspective, you'll say Spack external find and the Spack name for that package, regardless of what the distro calls it. And if we do a Spack find -cl netlib scalapack, we'll see exactly what we would expect, that we're back to 4 different installations of it again. Okay. There are some other useful features of environments. I'm not going to talk much about mirrors now because we're going to have a whole section on mirrors later on and pushing to binary caches and all of that. And similarly, I'm not going to talk about installing in parallel to save time, but that's another thing that you can look for in the documentation. The next thing we're going to really talk about in depth is exposing this software to users. So there are 2 primary ways besides Spack itself that you can expose the software in Spack to users. One is what we call a view. And a view is basically an alternative file system layout that strips away some of the complexity of the Spack install prefixes to make it easier for users to see the package. So it's basically a symlink tree of the software in the layout that you want to expose it to users. And in any environment in Spack can have a view associated with it. We've seen that already when Caetano was talking yesterday. Or it can have multiple views. So we're going to edit our environment again. I'm going to get rid of this view false. We're not doing that anymore. And I'm going to copy over this, this view configuration and then talk about what it says. So there are two views here. The first view is default, and this is the one that will be added to your path variables, man path, path, etc., when you activate the environment. So generally, what you want for the default view is a consistent set of software that can all be used together like you would get with Unify True. So in our environment, we said, okay, we want our default, we're going to customize the path for this default view. And to get a consistent set of software, we're going to say we only want to select the things built with GCC 12. We don't want any of the dependencies from bootstrapping our environment to show up in our view. And that's not even enough to get a consistent environment. But if we exclude everything built with mpitch and everything built with netlib/lapack, we get a consistent environment built with OpenMPI and OpenBLAS. Modules are the next thing I'm going to talk about, Alfred, so hold on to that for a second. And then we've got a full view, which here's the other way we can handle it. Instead of restricting what goes into the view to make sure there's no conflicts, we can increase the complexity of the view. We can set up projections and say, okay, if a package depends on MPI and LAPACK, we're going to give it this name based on its name, its version, its C dependency name, its C dependency version, the MPI name and version, and the LAPACK name and version. If it just depends on LAPACK, we'll exclude the MPI information and do the same thing. Now for these, maybe technically we should have said if it depends on MPI and LAPACK and C, but we happen to know that everything we're dealing with that depends on either of those, that depends on LAPACK, also depends on C. And then for things that use a C compiler, we name them with the C compiler. If they don't, but they use a C++ compiler, we name them with that, or the Fortran compiler. And if they're not compiled at all, they just get the name and the version. And the way these projections are evaluated, each spec is checked against the first projection. If it satisfies that, it gets that. Then it's checked against the second one, etc., on, until you get to all. Now, all, it doesn't matter where you put it in the list, but if you put it at the bottom of the list, you're much less likely to confuse yourself because then it works just the way you would expect for fall through. So with that view, we're going to Spack concretize again, just because concretization also regenerates any changes to the view. And we're going to take a look at the file system at these views. We're going to say stacks views default. This looks like a Unix prefix, kind of like what we would expect. And in lib, it's got a whole lot of stuff. So we're actually going to go back, and before we continue to look at the full view, we're going to spack config edit again and look at one more option for the view. And that is link roots. So link can be all or roots. And link roots just means we don't link the dependencies in. We only link the root specs of this environment into our view. So we'll spack concretize again. It'll regenerate that view. It only had to change one of the views because the other one hadn't changed. And now if we look in the view, we get a much more manageable list of things because the things installed in our environment were really Scalapack and the various netlib Scalapacks. We look in here, it only has a lib directory because that's all that they have. Now, if we look at our full environment, If you're wondering about the GCC that was a root, it got excluded by the because it was built with GCC 11. So we could have explicitly included it if we wanted to. If we look at the full view, we'll see there's the names, right? Everything was versioned based on its name. We can see the names. If we look in netlib scalapack, we can see there's options for each of the combinations that we built. If we look at, say, OpenBLAS instead, there's options, just the one option for the one compiler that it was built with. So that's Spack views. So now we're going to talk about generating module files for our stack. So the first thing we're going to need to do is we're going to need to make sure that we have a module system available. And we're only going to talk about LMOD module files for today. There is capability in Spack to generate Tickle modules as well. There's just not sufficient time in the tutorial to talk about both. A lot of the same principles apply, but a lot of the, obviously the things about LMOD hierarchies don't. So we're going to add LMOD, and we're going to build it with GCC 11 because that's kind of our system compiler, the same way that we bootstrapped our compiler. Not necessary to do it that way. And we're going to concretize. And once that concretization comes back, we're going to install to get LMOD. And then the next thing that we're going to have to do is, one, we're going to have to initialize modules in our environment. This is something that typically, as HPC users, we don't think about because someone sets it up in the default profile for the supercomputers. But if we're setting it up ourselves, we're going to have to do that. I'm going to install it real quick and then keep talking. And then the other thing that we're going to have to do is we're going to have to configure Spack to generate module files. And it used to be that Spack, by default, generated module files automatically. And we did a pretty substantial user survey, and we found that literally 0 users used the default configuration modules anyway. So we figured as long as you have to edit the config, you might as well turn the modules on. Okay, so before we go to talking about the module config itself, we're going to say we're going to source this file. It's in the LMOD prefix, so the Spack install location for LMOD. It's /lmod/lmod/init/bash. It's one of my favorite paths. And we've got LMOD available now. And now we're going to set some module configuration. So Spack config edit. And we're going to turn off the view again. There's no reason you can't have both a view and module files. We're just going to turn it off so that we don't have to wait for the view to regenerate. It's not that long, but it can be annoying. And then we're going to set up the modules. And I'm going to copy and paste this simply so that my editor can't try to insert any tabs, which YAML won't be happy about. But we're going to say, okay, we have modules. We have only one module set, and we'll call it default. We're going to enable LMOD. This is where you could enable Tickle instead. We're going to configure a root directory within our environment for where we want those modules to be stored. That doesn't have to be inside the environment. We could give it a relative path outside or an absolute path. And then for the LMOD hierarchy, the compiler is always part of the LMOD hierarchy, but we have to say what other virtual packages we want to have in the LMOD hierarchy. So in our case, with the environment that we put together, it's going to make sense to do MPI and LAPACK in the LMOD hierarchy, which is maybe a deeper LMOD hierarchy than folks are used to. And then this last thing, Spack has some capability to try to auto-detect what your core compiler is and automatically put things built with the core compiler in core. If you're familiar with LMOD hierarchies, that's kind of the default area, and everything else gets separated out by compilers. But that functionality has had a bit of a regression that we just discovered recently. So we can always help it along by saying the core specs, anything built with GCC at 11 is belongs in core. And now Spack concretize doesn't automatically regenerate the modules, but we can say Spack module lmod refresh, and it's going to say, do you really want to generate all these modules? I'm going to say yes. And it's going to take not too long to regenerate all those module files, but it'll take a moment. And then the last thing that we're going to have to do before we can use these modules is we're going to have to module use the directory that the modules are coming from. So we're going to module use stacks/modules. I'm just going to put a tilde slash on the front to be safe. Linux, Ubuntu 2204, x86 64. That's the family of architectures that we've built for. And we're going to use that core space. And now we can say module AV, which is short for module avail. And we get a lot of really ugly looking module files, but we do have all the module files that we would expect. So we can module load GCC, and which GCC. Okay, now it's in our path. And module avail again, and we see all of these things that were built with that GCC are now available as well. A few issues here. For one, there's a bunch of modules for the things that we used just to build up our environment to the point of building GCC that we probably don't want. For another, like I said, the module names are ugly. We probably don't want that. And then there's also just these modules might not be perfect for some of these things, right? If we look at module show OpenMPI, right, it might not have some variables that we care about. So we're going to unload all any modules we just loaded. I guess it was just GCC. I could have just module unloaded GCC. And we're going to add some more configurations. So we're going to spack config edit. And you can see it did this core compilers detection that we weren't relying on. And we can add some more things. I'm going to just delete the core compilers since it doesn't matter, and to keep things simpler looking. Hash length 0. So that's saying don't include the hashes at all. We're going to include GCC and exclude everything built with GCC at 11.4.0. So really these two go together, right? It's exclude first, everything built with 11.4.0, but we're going to include the GCC anyway. Okay, now I'm going to switch to copy and pasting to avoid Emacs trying to add tabs here, but I'll talk through all of these after I've pasted them in. So then we're going to, for all packages, we're going to set in the environment set by the module, we're going to set a name a variable named foo underscore root for whatever package it is, right? This is going to take the package name. It's going to automatically uppercase it. And we're going to set that to be the prefix of the spec. So this is a spec format string, just a very simple one. We saw some more complicated spec format strings in the projections earlier. And then for OpenMPI in particular, I'm going to set in that environment, I'm going to set slurm MPI type to PMI2. And this long variable that I am not going to read and I think was put in here as a prank on people trying to type it out, we're going to set that to 0. And then the last thing, we're going to set projections. But our projections can be pretty simple because the LMOD hierarchy takes care of most of it for us, right? It separates things by compiler, by MPI, by LAPACK. That's all of the combinatorial complexity in our environment already. So that means that it's very nice. We can use exactly the module name that we would most like, which is the package name and the version, right? That's what we would have seen in other places at supercomputing sites where we've used the module system. So I'm going to close out of that. And I'm going to Spack module lmod refresh. And I'm going to add the delete tree option. By default, Spack will construct the new modules, but it won't delete old modules. And that's fine if the new ones are all the same packages as the old ones, or you're only adding new packages and you haven't changed the layout. But if you have changed the layout, you're going to want to add the delete tree argument. And yes, I do want to proceed. And now this will give us a much prettier set of modules. So we can do a module avail. We can load the GCC module. And here we go. Here's all the things that were built with GCC. And then if we module load OpenBLAS, we can see the things that were built with OpenBLAS. And lastly, module load OpenMPI. We can see the things built with OpenMPI. There's just the one. And module load netlib scalapack. And just to show off the functionality of LMOD for a second, if we module load mpitch, you'll see, okay, OpenMPI was unloaded, mpitch was loaded, and it had to reload the new netlib scalapack to be the one compatible with mpitch. So the way that LMOD manages this hierarchy works very nicely with the kind of combinatorial complexity from Spack. So the last thing we're going to do, module purge, and I'll do a despacktivate as well to get out of that environment. So what we've done here is kind of the smallest toy version that we could come up with of what a facility deployment with Spack would look like. You have a variety of packages that you're going to install of different combinatorial complexity with the whole range of MPI implementations, compilers, and BLAS implementations that you care about for your site. And you're going to install all of that. And then it's possible that all of your users are Spack whizzes already, but more likely you're going to want some other way of exposing that software to the users. And that's going to be either a view or module files, or in a lot of cases, both. So with all that, I am going to stop sharing my screen and start answering questions in chat. And I will turn things over to Tammy to talk about package creation.
Hello and welcome to the package creation section of the Spack tutorial. So far, we've covered how to use Spack to install software, uninstall software, create environments, customize your Spack instance, customize your environments. All right, so like I said, we're going to switch gears and look at, so everything you've been doing has been based on packages other people have contributed to Spack. And so we want to switch gears now, and we'll go through kind of an iterative process to create and debug a simple Spack package of our own. We're going to start with this little, okay, I can't see the right side of the terminal seems to be what's going on here. I guess I'll let somebody else tell me. So we're going to use MPI Leaks as our software, and my tip is to go ahead and bring that up in the repository up in your browser so that you have access to it. It looks like I need to increase the size of that as well. So here's the MPI Leaks repository. And if you look at the, wow, I'd rather have a little bit more of that. Real estate. But if we look at what it has, you can look at the repository and we should be able to get a lot of what we need to fill in our package. So I do recommend you bring that up. Wow, this is so big. All right, so before we get started, let's kind of review. What is a Spack package? You've heard them referred to as recipes. They're installation scripts they basically define and tell Spack how to fetch the software, whether it has any software it depends on. So what are the dependencies? And you would specify those with the depends on directive. If the software has any options that you want to expose to the users, you would specify those in what are referred to as variant directives. If there are known build constraints with the software, for example, it doesn't build on, say, the Windows platform, then you would add conflicts directives. If there are any requirements, for example, it can only build with GCC or Clang, then you would add a requires directive. And so that we've provided links here to all of these, to the documentation for all of these capabilities or these ways to directives. And also build commands. Obviously, your package is going to have to specify anything or define, implement anything needed for Spack to build the software. As well as if you're adding tests, we have two forms of tests that we support in Spack, and I have the link here for that as well. Now, once you've created your Spack package and ideally tested it, ensure that it builds successfully on at least one platform, and that if you have any tests, they actually succeed, you can actually hand that off to someone else and then they can build your software, just as you've been doing with other people's packages. So before we get started, let's take some time to kind of create a little sandbox for us in terms of the repository, and also make it easier for us to clean up at the end of this tutorial. So the first thing we want to do is, okay, this is not quite what I was expecting. So somebody made some changes to this. All right, let's see if the Spack repo. Okay, I'm sorry. This is not what I was practicing yesterday and not what I was expecting. I guess we could go ahead and do this the way it's been changed, but we can see, oh gosh, I'm sorry. I have not set myself up for this environment yet. So,
Tammy, I think Alec found a small bug testing overnight, so that's why things have changed a little bit.
really? Okay, because that was working for me in the repository creation, and I gave it a different name so it wouldn't confuse things. But okay. All right. So let me see if I can run that command again. See if I can create the repository. And get this out.
You have to run Spack 1 because your user is Spack 1 instead of Spack for the home directory. Or you can replace the home
Fair
repos
enough.
with.
Yes, you're absolutely right. Okay. All right. So we've used the Spack repo create command to and provided the fully qualified path to the directory. I would rather have called this my packages, by the way, but if we look here, we have a repos directory, and Spack has gone ahead and created the desired or the required layout. I have to remember R, and so we can see that it creates this structure where it has a Spack repo. It has the name that we provided, so we give it a fully qualified path, Spack repo create, the name of the path, fully qualified path, and then the name of, call it tutorial, so the name of the repository. And Spack will generate, apparently it will create the directories for us, as well as generate the structure and create a repo.yaml file in that repository. Okay, and Spack kindly tells us what we need to do to basically register this newly created repository of ours. So Spack repo add, and it's going to be, we need to give it the fully qualified path name, Spack 1, repos, repo tutorial. We give it that, and now Spack has knows that we have this new package repository available to it. One of the things I want to do is kind of go through, let's look at what repositories we have. And we can see we have this tutorial repository that we just created as a local directory. We also have the freebie built-in repository that Spack gives us. And that by default lives in your .spack subdirectory of your home, your account's home directory. Yeah, they're just, so the package repositories are versioned, and I did not review what version 2. The difference with version 2.2 is versus the other ones, so I'd have to get back to you on that. Okay, so we have 2 repositories available to us, and another thing I wanted to kind of go through, if I can type, is that, and I can't type apparently, config get repos. So this is why calling it repos was unfortunate. Let's go ahead and look at how these are configured. So let's type spack config get the name or the path to the repository. And what we see here is basically the Spack will output the contents of the repos.yaml file that lives by default in this directory, your home, the .spack subdirectory of your home directory. And what we see here is, okay, here is our tutorial, and we know tutorial package repository, we know where it is, and there's also a built-in package repository that Spack gave us. It is a Git repository, and the HTTPS protocol was used to retrieve it, but this is the Spack packages, the new location of where we keep Spack packages for the community. It is, Spack used the July 2025 release branch, and assuming you did the update in the basics tutorial yesterday or today, then we have this particular tag from there. Okay, so if you want to know more about, I'm gonna close this off a little bit. I guess I can see why Greg had his screen the way he did. This is okay. So if you want to learn more, there are links here to the docs for the packages repository. And as I mentioned, the repos.yaml, you can see the structure and more information, as well as, you know, what are the versions, as well as the Spack repo command, the one that we've been using. And this is going to be handy if you actually want to contribute packages back to Spack. You're going to want your built-in to be a version of the clone that a clone of Spack packages that you can actually contribute to. Excuse me. All right, so now that we've covered that, let's look at starting our creation of the package, our own package file. I did have here, there is a note, if you missed it, I did paste it in chat about how to control the editor. We've got a new section in the documentation on this, very cool. If you've got a couple of environment variables and options, it's back now defaults for you. So there's some, what I think are some cool features. All right, so let's see. In order to create the package, we have to tell Spack how to fetch the code. And we need to tell Spack, did I miss something else here? No. All right, sorry. We're going to tell Spack how to fetch the code. Spack will, using the Spack create command, and we will get a skeleton, and then Spack will automatically, with the Spack create command, pull the new package up in your editor of choice. Because there is an MPI leaks package already and built in, so not only do we have our own tutorial repository, let's go ahead and make sure, just to make another layer of, to avoid confusion, let's give it a distinct name. So we're going to want to Spack create, and let's call it tutorial MPI leaks, and then we need to give the command, wow. Like the way these things are laid out. We need to give the command the URL to a source archive. And so we can see here on the MPI leaks repository page that there are releases. There's a version 1.0. I'm going to copy this link here for the source code, the archive, and paste that link and hit return. And we see that Spack, sorry, this is awkward for me. With this as large as it is. But we can see that Spack basically gave us, can I enlarge that at all? Spack gave us a copy of the package. Which URL do people are asking for the URL to be pasted? I don't think do I have access to chat? Can somebody paste that URL for me? Or you can get it from the Spack documentation for the section of the tutorial. It's in there as well. Thank you. All right, so we have here, let's take a few minutes to look at what we've been given. And we can see that there is this copyright at the top. This is the Spack copyright and the license. Please, if you plan to contribute your packages back, do not remove those. If it's only for personal use, that's fine, but we do ask that you not remove them if you're going to. Wow, some things aren't quite working the way I expect. All right, and then we have this boilerplate here, just providing you some information for, if you're going to contribute it back, we want you to remove this section of the code and address all of the fix me's. And we're giving you kind of the command for how to install the package and the command for editing it. So a few nice things about that. What we can see here is that Spack also, as it staged that archive file and investigated or looked at the source code, it determined that it was an AutoTools package and already added the import that you need now for an AutoTools package. It's creating a package class for you with the name derived from the one you provided, and is inheriting from an AutoTools package so that you get some of the benefits of that we already have, some associated with some standards related to building software that's an AutoTools package. We have a skeleton here, docstring. This is important for conveying to other people what your software does, and we'll see that in a little bit. Spack does not go through the process of trying to figure out what the homepage should be. So it just gives us an example homepage that we'll need to change. It does, we gave it an archive file, so it did fill out the URL property for us. There's the maintainers. Here we do encourage, if you if you're contributing a package, even if you're not the person who wrote the software, please do consider adding yourself as a maintainer. And what you do here is you would put your GitHub user account and the GitHub user account of anyone else you know of who cares and is willing to be a maintainer on the package. We also have the license. We do ask that you fill this in, and we'll go over that shortly. There is the first directive. We have a version directive that Spack has. It derived the 1.0 from that archive file, URL and file, the files, associated files that we gave it, and it calculated a SHA-256. Spack also determined by inspecting the source that there is, it requires C, C++, and Fortran to build. So it's added the depends on directives for us for those. And it's determined that it needs autoconf, automake, libtool, and M4 as well to build. And then we give you a little extra skeleton here. And as an auto reconf build system, it gives us a default auto reconf command that you can customize as needed, and a configure args method skeleton. So if you need to add any arguments here, we do ask that if you don't have arguments to add to your package, replace, just get rid of this line and replace this with the empty list. Okay, so now let's look at what we want to remove from here. We'll need to modify everything. If you go ahead and look in the tutorial section, we've highlighted what sections that we need you to update. A little bit more information on the maintainers. I'm gonna go ahead and exit out of this because Spack already saved that skeleton. And let's look at how did Spack determine what that version directive should contain in terms of the SHA-256. Well, Spack calculated it using the Spack checksum command. And if we enter that in, you can see that Spack pulled the URL and it calculated the checksum for us and nicely formatted it so that we could copy and paste it from here. If there were a version 2.10 or another version that differed only by this version number, Spack could actually automatically figure that out and give us the version directive for it as well. But that, if we look at the repository, it only has 1.0. All right, so most of the time you're going to have to make more changes, but let's go ahead and see what happens if we try to build the package. Which checksum is different. You probably have different dependencies. Okay, so let's go ahead and try and build it. That is odd that you have a different checksum. Sorry, I'm going to try to focus on this instead. Let's see. So let's see if we can install the software. And I hope right now we're concretizing. Aha, I can't get to the chat. While we wait for concretization, what am I missing? Oh, don't put the, so worksheet, don't put the 1.0 on that, right? Is it somebody else answered that question? Okay.
Yeah.
All right. Okay, so we can see here.
Tammy,
sorry.
so we're tight on time, so why don't you keep moving and Alec and I will answer questions and make sure to keep people, help people keep up with you.
All right. All right. Thank you. I'm gonna get that out of the way so I don't get distracted then. Okay, so we see that the build failed in configuration. It said unable to locate adept utils installation. Anybody familiar with auto tools packages would know what the problem is, but let's let's operate under the assumption that we don't know what the solution is here. But what can we determine from here? And if we look, we can see that, let's see. Well, since we're tight for time, I'm going to skip that. Why don't we go ahead and start changing our package? Bring the package up in an editor. So Spack edit, tutorial MPI leaks. Okay. And we'll start with just getting, cleaning up the documentation. So let's go ahead and delete these lines. Let's fill in the description. And as I mentioned, it's handy to have, wow. Okay, so I'm going to go ahead and take the description from the repository and add that as our doc string for the package. Now, I'm not seeing anything here that shows me that they have some other web page as their home page, so I'm going to take that as the home page, the URL for the repository, and replace that. Then we want to go down here, and as I said, please do consider adding yourself as a maintainer for a package, even if it's not software that you developed. And then let's go ahead and fix the license while we're at it. So this is more documentation. What we can see here is there's a view license. And right here, we can see it's a BSD license. So we can paste that in and change this. And go ahead and save what you have. And let's look at what that buys us. So these are the changes we should see. And let's go ahead and look at what it buys us. We're going to run Spack info so we can get information about the package. This is something that we would expect someone who wants to use your software to run. And we're going to go ahead and add the -- phases option to it since we need that in order to see an important piece of information from here. So we want to look at here is the description that we gave, and this is why it's important to have a, fill in that doc string so that people can see what your software does if they run this command. And try not to have it too long. Some people get very verbose, but this is one of the key reasons for having that description. We can also see that that the version that we had added through the URL is 1.0. That Spack considers it a safe version because it was able to calculate a checksum. So any hash commit would have SHA-256 would kind of qualify it as a safe version. All packages have now have a build system variant, an implicit build system variant. In this case, it's the auto tools that was derived. Because we did the phases option, we can see that it inherits these installation phases, the default installation phases for auto tools. So the auto reconf, configure, build, install. We can also see that it gets some those language dependencies that it had, as well as the autocomp and the libtool 1 and 4. But it also adds the gmake and GNU config that build dependencies that it inherits from auto tools package. We also notice that at this point there are no link or run dependencies because we haven't set them up. And we do see the license that we added.
So,
okay, so now
on that note,
go ahead.
we're 15 minutes past when we were originally supposed to take a break. So we should probably take a quick 5-minute break here.
Okay, let's see. All right, now let's start filling in this installation script or filling in our package. We'll start by looking at the dependencies. And if we go back to the repository, And if I can figure out how to navigate this, if we look at the README file, let's see, does it provide any hints? Well, obviously MPI leaks, so we will have to do include MPI. And if we scroll down here, we can also see other, but we'll turn a blind eye to part of it, but we can see that adept utils and call path. I think call path is mentioned up here as well. So we know that from looking at the repository that we'll need to add MPI, adept utils, and call path to our dependencies. So let's go ahead and edit our package. Let's just go ahead and add our dependencies. So go here, MPI, adept utils. We're not even going to, and call path. Okay, so we're going to add them there. I think it's important to note that, or it is important to note that MPI is actually, it's the message passing interface for those who aren't familiar with that. That means it is basically it's a virtual dependency. It doesn't have an implementation of its own, but there are other packages that will implement that interface. And so the packages such as OpenMPI and InVapItch, and we call those packages providers. There is a link here on virtual dependencies if you want to find out a bit more information. Okay, so let's go ahead and save it off with those two dependencies and install our package. Hopefully concretization doesn't take too long. And as that is working, what we can see here, I'm going to enlarge this. So do we want to, sorry, I will not scroll too fast. So we want to add MPI, adept utils, and call path. Fortunately for us, there are packages already for adept utils and call path. So we don't have to create those packages ourselves. All right, there we go. So the install is working. And if we look at the output, what we can see is right-hand side's going a little too fast for me. What do we see here? We can see that adept utils was successfully installed. Above it, we can see that OpenMPI was chosen as our MPI provider by the concretizer. And we can see that call path was successfully installed as well. However, that is not enough for us to be able to build this package, and we are getting the same error that we had before. We already covered that. So let's go ahead and look at what can you do to debug a package that you're building or adding to. So we have two options. We can review the build log, which Spack has conveniently given us the path to here. And we can build the package manually. So if you cat that build log, what you're going to see is basically the information that we see above, and that our error is that Spack or configure cannot find out where adapt utils lives, the installation of it lives. So we're going to have to be explicit. Now Spack does automatically add standard including with library directories to the compiler search path, but you know, sometimes it's not enough. So we're going to have to be explicit. So let's go ahead and practice a little bit with what it takes to manually build a Spack package. We're going to want to cd to the directory, the stage directory. No, I didn't realize this takes. If that takes too long, you can always cd to this location. Okay, should I be impatient and not? How long does this command take these days? I'm gonna Can I kill that off? Or was that a bad idea?
It concretizes, so it was just waiting for the concretization to come back.
Got it. Yeah, well, that's what I figured. Okay, so if we go to that stage directory, the Spack stage directory, we see here a Spack source directory. This is where Spack basically extracts the archive file. So we can see there are a number of output files that can be helpful for debugging, but let's ignore that and just go into Spack source. And now that we're here, one of the other things that we have to do is we need to make sure that we have that build environment set up for us. You know, all the environment settings and information that Spack needs to build the software. So let's go ahead and take this Spack build-env command and give it the name of our package, and then you want to give it a shell, the name of a shell. So I'm going to go ahead and take that, paste it in. And now Spack is going to set up the environment for us so that we can actually perform the build. Okay. And then once that's done, this is an auto tools package. It has a configure command. We saw that right here. And anyone familiar with configure knows that you can run configure and get some information. Now, I'm not going to go ahead and repeat this configure with the prefix, but you can repeat the configure command with prefix, and you would just grab the prefix from the output above. But let's instead go ahead and jump to calling configure help, because that's really what we need to find out here, what's going on. So if we look at the help output from configure, and we scroll down, a lot of standard configure options, but keep going, optional packages. And here's our adept utils and call path. So both of them require a path argument. We only saw that adept utils was complaining, but actually both require the path to the installation. Let's go ahead and exit out of that build environment, cd to our Spack root, our Spack instance, and start specifying configure arguments. Now, there's a link here for more information on what that means. But for our purposes, let's go ahead and bring up our package in the editor and add the paths. Now, one of the things Spack does, and we're going to add those to configure args. I'm going to get rid of that. And, oh, while I'm at it, I'm going to get rid of this fix me as well. And what we need to do here is to set the arguments. Now, Spack has a convenient data structure for us. So there's the self.spec, and all we have to give it is the name of the dependency and pass that with its dot prefix, the resulting structures dot prefix property, and that will automatically provide us with the installation path for adept utils, similarly for call path. And one thing I would like to point out is we are using F strings, and we do encourage people to use Python format strings. I'm just going to take this, copy and paste this code here, and make sure everything's good there, and go ahead and save what we've done, exit out, and install one. I wish I paid more attention to where that was. So now let's see how far we can get with the installation. Well, we peaked. So waiting for concretization right now. Are there any questions I should answer? Anything in chat, or should I go ahead and just kind of try to speed through here?
No, I think you're fine. The big conversation in chat has been about the build env command and the fact that it doesn't have an option to add something to the prompt. The way that the Spack env activate command does, and that's maybe something we should consider.
Ah, okay, okay. Yeah. I have to check out the chat when I'm done. Okay, so success. Everything went well. All right, so now remember one of the things you can do is you can expose options, optional features in the software in the Spack package so that people can use those options when they're building through Spack. And what we want to do here is we can actually add some variants, because if we go back to the configures help and those optional packages, there were a couple of additional options we could put in, excuse me, called with stack start. There's one for C and one for Fortran, and they have an integer number of MPI leaks. What's it? Basically stacks for the C code and for the Fortran. Now, both the Fortran, I think, stack is a little bit deeper than the C, but basically we want to chop off the top so many lines of the stack in the output so that you're not seeing stack things, if I remember correctly. Okay, so let's go ahead and look at adding the directive, a variant directive. So adding an option to our package. It's an int type because it's the number of lines. We're going to default it to 0 because 0 will effectively disable it, right? And any positive number would represent the number of lines to be shaved off. So let's edit our package. No, we don't show running it with that. That was the question I just saw. So let's go ahead and edit our package. And we want to go up and add, we'll have to take two steps. We have our version section. We have a dependency section. Let's go ahead and add the variants, since variants represent options in the build. I'm going to start the variant section of the package and simply copy and paste this variant directive into my package. Now what we're doing here is just for simplicity, call it stack start. The values are going to be integer values. The default is going to be 0, and I'm giving a nice helpful description to what the variant is. So we've added the variant, but we need to now use that variant. And we do that by adding config arguments. Again, 0 means disabled. So let's go ahead. I'm going to copy and paste this and then explain what's happening here. So here's the code for it. And what does this mean? Well, for simplicity, stack start. So the variant structure that Spack provides in the spec is also a dictionary. And all we have to do is use the name of the variant that we had. And that structure has a value property. So we can access that with the self.spec.variance of stack start and its value. And we want to cast it to an integer to get the value we need here, stack start. Then we can check, do we have a value? And if we do, we're going to extend our arguments list with the two configure arguments, with stack start C, with stack start Fortran, and have the value placed in there. Okay, so save that off. And let's go ahead and run again the installation, but let's give a stack start option. And we're going to go ahead and add verbose, type verbose. Basically the command here. So let's do a verbose installation and provide that variant option. Uh-oh, what did I do wrong? Did I do something wrong?
Start instead of start.
Oh. Thank you. Can't type today. Stack start. Did I do it again?
You need to set value equals int.
Did I not do that already?
Right.
Values int.
Okay.
Int.
This is a regression. We'll fix that, but for now to move forward, get rid of or change value to stir. Wait,
I'm
it's
sorry.
looking for Davide. Okay. Robert had to change the default value to the string equals.
Oh, I'm sorry. I should have looked at that. I'm sorry. Yeah.
But Davide said it worked.
Oop. Like that? Is that what it was complaining about? I don't see the output again anymore.
Yeah, that's what it was saying, but with values equals stir, it shouldn't need that, but we'll keep going with that.
Default value for text start is not a boolean or string default. Did you mean? Oh, interesting. Okay, that hasn't been the case before, but see what happens. Okay, so we're going through the concretization again. And what we should see here as it proceeds is, let me see if I can find what I care about. We look here, checking, getting the tool. That is, I need to be way higher here. Configure, auto recomp. So we get to configure stage. And if we look here, we go all the way to the end, we can see that our prefix is there. So there's the adept utils. You see here the prefix for adept utils where it was installed. We can see that call path prefix is there, the installation prefix, and we can see our stack start for and our stacks for C and for Fortran. What's the easiest way to get back on this? I don't remember, there's supposed to be a quick way to get over there. So we can see that the options were passed in and it succeeded. Okay. Now we can add tests here. If you look at the installation, which I'm going to try and speed up a little bit here. If we looked at the installation of the software, we would see that there are 3 directories. So this is the simplest test we could have or check we could have for the installation is what's referred to as a sanity check, where you can check to see if there are directories and or files. And this, again, there's bin, lib, and share. So the simplest thing we can do is add a sanity check. But let's go ahead and make a mistake real quick, and maybe we don't. We see the license. This is a property, so let's go ahead and put it above the directives. Yeah, I messed that up. With a mistake, so if we have a mistake, actually, I wonder if I should speed that up. If we have the mistake, we save that, save this off. So binlib char, and we were to run it, we would see that it would fail. But before we can build it, we do have to uninstall what we have already because the tests aren't part of the hash. So we have to uninstall the package first and then reinstall it in order for these build time checks. So a sanity check is a build time test, and we have to actually pass it the test equals root option. So we would reinstall with test equals root, and we would see that it actually fails. And the error is install failed for tutorial MPI leaks because of that invalid unknown no such directory. Then we can go back in, and I'm going to go ahead and, for the sake of time, put the correct one in, the correct path name, and then oh, and I didn't do the uninstall, so I'll have to Spack uninstall. All yes, tutorial MPI leaks. So let me uninstall the one that I had before, and then let's reinstall. Yeah, MPI leaks. I should have just done a replacement. And run the -- test equals root option, so we can run the build time tests, which in this particular case we only have a sanity check. So there, while that's concretizing and everything, there are links here in this section of the tutorial to go over post-install phase tests. So in addition to other build time checks, so there are the sanity checks. As I said, you can do files, which would be a list of files. You can have as a property and a list of directories. Those are options. You can also have installation phase tests. And we can see for some of the build systems, there are automatic checks. So after the build phase of an AutoTools package, if the makefile has a test or a check target, then Spack will run a package's check method to execute those. And if it has an install check, if the makefile has an install check method in it, then in the post-install phase, Spack would automatically run that. So there is this table here for some of the checks that are build time checks that are automatically performed. Again, you have to have the test equals root option set. You can also customize as well. And then there are, and we won't cover them, standalone tests. So there's a link here to talk about how you can add test methods whose names start with test underscore to add more testing capability to it. Okay, so our build worked, the tests passed, the installation was good, at least from a sanity check perspective. Now we've seen a couple of ways to check the spec object. When you're building or you're running tests, you may need to customize what's going on. So you can actually check how a package's dependencies were built, how what compiler was used, what version of the package is being installed by your spec install command, what variants were specified implicitly or explicitly. So you can use these version ranges. So use self.spec.satisfies with a version range check. So it's a minimum of 1.1 in this example. Here's an upper bound of 5.0, and so it'd be 5.0 well, yeah, 5.0 in this case. Here's a check of, remember that spec object is a dictionary, so you could have a dependency as name is the key, and you can see if it satisfies some range check. We don't show it, but these the spec.satisfies could also have variant values if that's relevant, like plus debug or something. You can also query spec names. So we have that virtual package, the MPI. If it matters for your build or for your tests, whether it's Open MPI or Mvapage or whatever other MPI you might have, you can check the name, use the name property of the MPI spec and figure out which one it is and customize using that. If you have variants, so here's a Boolean variant. If the Boolean variant is enabled in the spec, you can change things in your build or, like I said, your tests. There are other mini packages you can look at. The Spack packages repository. You would look at the packages directly in this subdirectory, or you can use Spack package grep command to perform a query, and it will check all of the packages in all of the repositories you have configured. So here's an example of a query to look for any auto tools packages that are in there and list the paths to them. All right, then we have multiple build systems. This is a very simplified look at Uncrustify. It has evolved, but it does represent a package that has used two different build systems, one earlier on and a different build system for newer versions. Other cases where you might have multiple build systems are, maybe you support multiple build systems at the same time, or, maybe you need a different build system on depending on the platform. So here's a simplified version of Uncrustify with versions, and it's from basically what you do is you'll inherit from those. We don't have the imports, but we would have to import those build systems as well. And then you need to use the build systems directive with conditionals to indicate when, if it's the case of, like the case of Uncrustify, where it's any version from 0.64 on uses CMake, and any version up through 0.63 would use auto tools. And here's an example of a multi-valued variant check. We're using this with Win on that and adding dependencies for it because we now need to have those dependencies specified. What else? Another thing that is different in this case is you might have to customize the builders associated with these packages. So there's a CMake builder and an auto tools builder. So if you need to add CMake arguments and configure arguments, you'll need to implement these methods. Okay, so that is all we have. Let's go ahead and uninstall what we have. So we'll uninstall the tutorial MPI leaks. Let's go ahead and remove the repository. So we took that tutorial MPI leaks implementation out, or installation out of our Spack instances install directory. Let's go ahead and remove the tutorial from our repos.yaml configuration. And then, okay, so I actually would rather just get rid of everything there, right? That whole repository, because we have, oh, go to, good thing I looked. I needed to, oh, I am at Spack root. I want to be at CD, home directory. So there's my, I want to get rid of that. And I want to go ahead and get rid of this whole repos subdirectory. So got to be in the right place. All right, and that's all I have. There is more information here. Our documentation, the packaging guide has been split into 4 sections. So there are links to each one here. If you want more information on, customizing package-related environments, the testing, as I said, there's build time and standalone tests, so you can investigate those. Other build systems, the Godal package link has been fixed, so it does link to the Spack packages repository. And you can see a very interesting example of a package that has 2 build systems and extends Python. So, and then, Peter was talking about or was it Greg? The Spack external find. If you want to make your package discoverable through Spack external find, there's a link here on what you need to do for that. So that's all I have. Thank you for your time.
So now we're going to talk about the developer workflows. So we've seen how, so far in the tutorial, you've all seen how we can use Spack to install packages from downloaded source code. But we also support a developer workflow where you can work with source code locally. And some reasons you might want to do this are if you wanted to make changes to an existing release, or if you're working on code from a Git repo. And when you're iterating on local source code like that, you're going to be constantly editing, building, running changes to the package or to your source code. And we want to be able to quickly have a quick turnaround time for that. And that's where our Spack develop comes in, where the main point is to iterate quickly on your source code while also your dependencies are still being managed in the way that Spack's primary function is. So let's imagine that for this example, we're going to be working on SCR, and SCR is a library used to implement scalable checkpointing in application codes. It supports writing and reading checkpoints quickly and efficiently using MPI and high bandwidth file I/O. So say that we wanted to test changes in that, like we're developing it, we would like to test changes to SCR. And we want to do that within an actual application so we can see how those changes would affect a whole installation, its dependencies and dependents. So in order to test within an application, we're going to be testing SCR within a max.io build. And that's a proxy application written to mimic typical HPC I/O workloads. And we've just chosen these because they are quick to build and go together. So the first thing that we're going to do, oh, also, are we all good on size? The first thing that we need to do is create a different environment for our development. So we're going to go back to our home directory and we're going to make a directory called devel.env for our development environment. So make dir devel.env. And then we're going to go into that directory. And as we are familiar with now, we're going to spack env create -d. And since we're in the directory, just dot. And now we've created our independent environment.
Sorry, Kathleen, people are asking if you can make the docs a bit bigger.
Sure. Is that better?
Works
Yeah,
for
looks
me.
good. No one's asking for anything bigger.
Okay, good. All right, so we created our environment. Now we're going to activate it with either that spec and create activate period or a spactivate period. And so now that's activated. And for now, we're just going to disable Fortran support in all packages just to make this run a little bit faster. So we're going to run spack config add in quotes packages colon all colon variants colon tilde to disable Fortran. So now we can run spack install. Oh, just kidding. I skipped main thing. We're going to add max.io with SCR support are enabled. Okay, I forgot the keyword there again. Spack add max.io plus SCR. Okay, and now we can install those in our environment with spack install. And we can see over here at this output that it's going to have concretized one spec of the max.io with SCR as well. And so while we're waiting for all that to build, we can just look at this diagram of what might be happening. So we have like max.io here, and then if we have SCR, it's just going to be, we're going to be able to update, make changes to SCR. Well, then that would also update max.io when we run those changes. So let's assume that SCR has a bug and we'd like to patch SCR to find out what the problem is. So the first thing that we need to do is check out the version of SCR that we want to work on. And in this case, it'll be the 3.1.0 release. So we want to specify that version. When we're running Spack develop, so we're going to write Spack develop SCR within this environment and specifically at version 3.1.0. And if we wanted to see what that develop command did, we can, let's just run grep -3, develop the spack.yaml file. And we can see that this develop section now has SCR and the specific SCR under our development section in our spack.yaml. So that develop command marks the package as being a development package, and that adds a special dev path attribute to the spec. So Spack can remember that that's where the source code for this package is located that we're developing. And by default, the source code is downloaded into a subdirectory of the environment. So the things that you want to keep in mind with running this Spack develop command is that first, you want to make sure that that version is specified like we did before, or if you didn't, it'll just go to the default latest version of SCR. And you also want to make sure that the packages are in your environment ahead of time. And finally, once you run this develop command, you need to reconcretize after that so that it can update with that development path. So we're going to run spack concretize -f because we just ran our development command for the first time, or just ran it at all. So that's going to reconcretize. And after we reconcretize it, we're also going to have to spack install again with the new concretization. And we just do that by running spack install once this concretizes. And what we can start, well, there we go. Okay, so now that's reconcretized and we can spack install with that new build plan with the developments filled in. And you can see that we're just pulling in all those same packages and that the only, oh, yeah, and so that we don't have to change everything. So now let's start mimicking how we will develop our code. So for the sake of this demo, we're just going to intentionally introduce an error so you could see what it would be like in the development process. So we're going to go into the source code for SCR, which, stick with me here, is Vim or whatever your editor is, SCR/src/scr underscore copy.c. And what we're going to do here is just delete the first semicolon we see because we know that that will introduce an error. So let's remove that, save it. And when you're in the development stages of or when you're developing a package, spack install works a lot like make, where it checks the file times on the source directory to see if we've made recent changes. And then if those file times are newer, it'll rebuild those packages instead of rebuilding the whole thing. So this will rebuild SCR and max.io because it's a dependent of it, but it won't rebuild all of our 86 packages, which is what helps that quick iterative process for spack develop. So let's now run spack install. And it's going to introduce an error just as we expect it to. But first you can see that it just brought in all those other packages and got stuck on SCR because that was the first thing that had been changed that we need to reinstall, or we needed to check that package and it found an error. So if you didn't know what the error was, because like you didn't intentionally add it, you can go to this build log for details, and there are a few different ways to view that. That's also shown in the documentation. So let's go right back in and to our local source code of SCR, src for the source, SCR copy.c, underscore copy.c. And let's just put that semicolon right back where it belongs. And run Spack install again. And it'll all go back to building properly as expected. And we'll see that it rebuilt SCR. And then since SCR had to be changed, its dependent of max.io also got changed, or also reran, and everything built correctly. So being able to take advantage of these iterative builds requires cooperation from your build system. So if it uses make, then this happens for free and CMake, but if you're using auto reconf, this can take some more time. So just keep that in mind when you're developing, that your build system may affect the amount of time and ease that developing has. So we're also not limited to only developing one package at a time. So say we also wanted to co-develop max.io while we're developing SCR. We can also just say, again, Spack develop max.io, concretize that, and now we also have max.io listed as one of the packages that we're developing in this environment and in our spack.yaml file. Which we can show once this concretizes. But another perk of this development workflow is that it lets you ship our whole development process to another developer on our team, or if we wanted to share it with someone else generally, we can just take that spack.yaml file, create a new environment, and then use this to replicate our build process for someone else, which is why it's very helpful for code teams. Now I'm just going to run that grep of what our develop command is again to show that now not only is SCR in there, but also max.io in this develop section. So let's mimic sharing, the process of sharing our development workflow with someone else. So let's cd back to our home directory. We're going to make a new environment directory. So make dir devel other, cd into that directory. And and then we're just going to copy over that spack.yaml file into this directory. So cp /develn for our other directory is located, and just take that spack.yaml file and copy it right here. Then let's spacktivate this environment with that new YAML file. And say Spack develop. And now we can see that we have max.io, SCR, that spack.yaml file, and all that local source code now over in this other directory that could just as easily be on another person's machine. So you can notice that we ran Spack develop with no arguments. That means it'll just check out or download the source code and place it in the appropriate places. And once we're all done developing, we just have a similar syntax of marking Spack undevelop. So we're going to simply tell Spack that we no longer need to keep a development version of these packages. So Spack undevelop SCR and max.io. Sorry, my Slack is bouncing down there, guys. Okay, so now it removed SCR and removed max.io. Again, if we go up to where we see what's in develop, we no longer have any packages marked as being developed. So yeah, you can use the Spack develop command with an environment to make a reproducible build environment for your development workflow, quickly iterate over those changes while your dependencies are still being managed, only have to rerun the the source code, or only rerun the packages that you really care about and the code you really care about, and also work collaboratively by sharing the developing packages.
Okay, so the first thing that we're going to do here is we're going to go export that token that we just grabbed. So I'm going to do my OCI token and shrink the WebEx window that is overlapping that. And then I'm just going to paste this in. Be careful to remove all of the front bits from that cell. We're going to go ahead and export that. This is for a test user on GitHub. We'll show the example or username and everything here in a second. Don't worry, that user doesn't have anything sensitive associated with them. And this token will expire in a couple of minutes after this tutorial. So next, we are going to go create our mirror that we're going to be using for this. So we'll do Spack-E. Oh, wait, there's, oops, got scrolled down in the change of everything. Okay, first of all, here, we're going to go create a directory. We're going to call it my env. And then we'll go ahead and cd into my env. From here, we're going to create a Spack environment. So we'll do Spack env create, as we learned in the environments tutorial earlier on. We're going to do with view dot. This is essentially saying we want to render out the view for this environment in the current working directory, and I'll show why we do that in just a second. Spack env create, oh, with hyphen view. We create, oh, with view. Okay, we're going to create that view in a directory called view. Next, we're going to run spack-e. We're just going to activate our environment. We're going to run spack env activate on our current directory. As you can see, we've got that Spack YAML that Spack rendered out for us. So now we're in the environment that is in this directory. We're going to run spack add Julia to add the Julia package to our environment. If we wanted to, we could take a look at that environment file and see we now have a Julia spec inside of here. And so now we'll go ahead and run Spack install to install Julia into our environment. And this is going to concretize, and then it's going to go pull down some of the Julia packages, or the Julia package and all of its dependencies that we need. After this, we're going to show that we have a working Julia binary by jumping into the REPL. After that, we're going to configure our mirror inside of this environment, and we're going to test pushing it up to the GitHub container registry. So while this is concretizing and installing, let me jump back a little bit and say, Spack has two types of mirrors. We have source cache mirrors and we have binary caches. Source caches download all of the source code that you would typically use for doing an install in Spack. Binary caches allow you to cache the pre-built binaries that you've gone and installed and then move them and reinstall them later on. That's exactly what we've been doing in this tutorial so far. We've been using the binary cache that we set up that's at /mir that has a whole bunch of those binaries just to speed things up. So here we're going to be creating our own binary cache. Spack can push to S3 buckets. It can push to just file paths like we've been using already in this tutorial. And it can also push to OCI registries. An OCI stands for the Open Container Initiative. It is really like Docker Hub is an OCI registry. So we're pushing up Spack binaries and we're flubbing a little bit. Spack is pushing up binaries that look like layers of a Docker file to Docker Hub or to another one of these container registries, such as GitHub. Or really the reason that we're using this is that most HPC sites at this point have a GitLab instance. And if you have a GitLab instance, you have access to the GitLab container registry. So it makes it really easy if you have, say, a CI/CD pipeline to go and install a bunch of things with Spack and then cache them into that GitLab container registry. So Julia's built for us, and we can now see we've got that view directory. If we jump into that view inside of bin, we'll have Julia. We launch it. We can see that we get the REPL. I'll just do a quick 1+1. And we'll jump out of the REPL. So we know we have a working Julia instance here. We want to take this pre-built Julia, we want to push it up to the GitHub registry so that then either we could be sharing this development environment, just as Kathleen was talking about in the previous section, with other members of our same team, or maybe we want to be caching this so that it's faster to bootstrap CI/CD pipelines like I was just talking about. So now we'll go ahead and we'll run spack mir add. I'm going to drop the -e dot here because we've already activated our environment. Spack -e allows you to activate an environment for the lifetime of that Spack command, so that you can just temporarily go operate on an environment without having to activate and deactivate it a whole bunch of times. But in this case, since we're in the activated environment, we're just going to run spack mir add. We're going to give it our OCI username. Instead of giving your GitHub username, that is typically what you would do, we're going to do spack-tutorial. That's the name of the GitHub user for which we created that token. We're also going to do OCI password variable. And so instead of putting our password directly into our unencrypted Spack environment config that you might want to share around in your team, we can instead reference an environment variable, and you could store that in a more encrypted way, for example, using password store. So here we'll finish writing this out and then say my OCI token. Again, we're going to do unsigned, which you guys saw a little bit earlier today, but this is just going to say, for the length of this tutorial and the amount of time that we have left today, I'm not going to walk everyone through how to create GPG keys and how to sign their Spack binaries. If you're really interested in that, feel free to send me a message on the Spack Slack. I'm happy to walk through it. It's also in the Spack documentation, so you can see examples there. Now we're also going to run my mirror for the name of the mirror that we're creating. And then we're also going to give it an OCI path. So I'm going to copy and paste a little bit here to reduce the chances of making errors. But OCI // GHCR, which is the GitHub container registry, .io / again, we're going to do spack-tutorial. We're going to do build cache. And then I'm going to copy and paste user and hostname. Typically, you don't need to put something like user and hostname in here, but in this case, because of the tutorial, we're all using the same GitHub user. And so the way to differentiate our build caches from each other are by using the hostname of each individual virtual machine that we're using, as well as the Spack 0 through 10 user on that machine. So we'll go ahead and run that. Now, if we want to take a look at our spack.yaml file, we'll see that Spack added in this mirrors section for a mirror, in this case, very nicely named my mirror. It's got our URL in there, so I'm operating on Spack 0, and then this is the host name. And we have it pointing at that secret variable that we exposed earlier. So now let's try pushing up to our build cache. We're going to run Spack build cache push. Again, I'm dropping that -e because we're already in the environment. My -mir. So this is going to go and check for existing packages up there on the GitHub container registry. In this case, since we're just creating this fresh, it's not going to go find any. So we're going to see it run through and push all 68 up there. And then while this is continuing to push, the next part we're going to talk about is essentially dropping the other mirror, that file system mirror that we've used, just to show that we're gonna pull down Julia back from the cache that we just pushed to. So now let's jump into our spack.yaml file. You can run spack config edit, and that'll jump you into there. Because I don't want to look like a floundering idiot inside of Vim, I'm going to jump into Emacs because that's what I know best. And here we're going to modify our mirror section. And so Peter talked about this earlier when talking about configuration, that this is all a set of nested dictionaries, and that we have this really handy syntax where you can have a double colon, and that will drop the layering of environments from other scopes. So as you can see here on the right, note the double colon. This will essentially blow away any other mirrors configuration that we might have configured on our system. And so this will blow away the mirror, the file system mirror that we configured earlier today. Note, this isn't going to delete that mirror or anything for you. It's just going to make it so that it's not present when you're in this active environment. So now again, let's run spack install. We're going to write overwrite, and let's reinstall Julia, just to see that now it is indeed going to come from online. So it's going to iterate through all of Julia's dependencies, saying, hey, yeah, we already have all those installed. And great, now once it gets to Julia, it says, I'm overwriting my installation of Julia, so no need to reuse that. And you'll see that it's pulling it out of that build cache location. If folks are interested, we can go to GitHub. If you go to your GitHub user, in this case, Spack tutorial, you click on packages. This is going to show all of the containers or all of the build caches that you've created with Spack. And so if we click into one of these, we'll see we have Julia, we have GCC, or excuse me, Gmake, as well as the compiler wrappers, curl. All of these packages now exist inside of here. So this is pretty cool on its own, but we can make this even cooler. Spack in the past has had a command called spack containerize. It still exists. Spack containerize will go render out like a Docker file that will run your Spack build inside of the Docker file. However, very often folks using that method say, hey, like my build crashed halfway through and the Docker container, because the build was ephemeral, lost all of its past history. And this is a really painful environment to do development work in, or this is a really painful environment to debug. You can bind mount in the location where Spack is doing the build inside of the Docker container. That is a great solution. But we can also just go do a Spack build on our machine. And as long as the operating of our machine matches the kind of what we would call like the base image of your container, we can actually just label our binary cache as having a base image, and then not using Spack at all, we can pull our binary cache back down and compile it up as a container. So you can have one member on your team use Spack to build up an environment, export it to a binary cache, and then anyone else on your team can just use Docker or Podman and load that environment inside of a container. It's really cool. So let's jump into an example of how to do that. First, we're going to run spack build cache. We're going to run update index on my mirror. And this is going to go read through everything that's in that binary cache, and it's going to create an index file. Once you have an index file, we can more easily go see Spack build cache list with all Arch. This is just a list of everything that we have in that current build cache. And so this is a nice way to see like, hey, look, we've got Julia as well as all of its dependencies. And Spack is reading this out of that manifest file in the build cache. So once we have an index and all of that, we are going to, and I'm going to skip a little bit of this for time, but essentially we can go back to where we did the build cache push my mirror, and we're going to add this flag base image, and we're going to do a force push of it with the base image. So we'll do dash dash force. And there's just the WebEx window is making this a little painful. Okay, so we'll do build cache push mynear. We're going to add in force. We're going to add in base image. And because the base image of all of these virtual machines is Ubuntu, we're again going to grab an Ubuntu container, and we're going to grab the 24.04 container for mynear. We're going to rerun this push. And now this time it's going to go repush all of the Spacks. And it's going to tag it. Oh, excuse me. I forgot to put the tag in there. Okay, we're going to add one more flag to this as well. So we're going to run force. We're going to add a base image. That would create a runnable container on its own, but it's a little bit of a pain because you have to grab this really ugly name out of the end of Julia, the version, and the hash. To make that even a little bit easier, we can add tag, and I'm just going to tag this full container image with everything in my environment is dash dash tag Julia. So now when we rerun this, we're going to repush back all of our specs. We're going to tag the composite of our environment as a container just called Julia, or as a tag on the build cache container called Julia. It's a little bit awkward, but and then I'll show you guys being able to then go run this with Docker, and that'll wrap us just about to the end of our day. Okay, perfect. So now it's going through and it's tagging all of those layers. So now, again, without any sense of having to have Spack on your machine. Oops, I have scrolled a little too far on that side. But without having to have Spack on your machine, we're going to do, first, we're going to do Docker login. And we're going to provide, oops, here. We're going to log into the ghcr.io container registry because we've been pushing this up with a username and a password. So for our username, we're going to do spack-tutorial again. And for our password, we're going to do that token that I pasted in here earlier. So I'll go ahead and grab that. Oops. See. Okay, there we go. The login succeeded. So now we're going to run docker run. We'll add --rm just to clean up the container after us. We'll run it in an interactive session. We're going to grab ghcr.io spack-tutorial. And then build cache with our user and our host. And then grab the tag out of that called Julia. Oops. Okay. Oh yeah, you're right. Host name. There we go. So this will go and pull each of these layers that you're seeing here is an individual Spack package, and then layering them all on top of each other, we get that full environment. So this drops us into the container, and here we can just run Julia, and that drops us into our Julia REPL. And I'll finish this out by showing that 1 + 1 = 2 in Julia again. So thank you all. This has been a really fun tutorial. Hopefully you guys have learned something new. Feel free to continue asking questions on the Spack Slack in the tutorial channel or in general or help as things come up. So
And
thank you all very much. And we'll stick along for a little while if people have questions here. Asher, in the case that you're still online, also this is a point of Spack that we're actively working on. It's a feature kind of called spiral dependencies, where one day we could have an environment bootstrap its own compiler and then build everything up from there.
Let's see, any way to reduce the size of Spack when many applications are installed? So there's a few occasions when people have this issue. Sometimes it's like Spack reinstalls dependencies like repeatedly, and they're like slight tweaks of things. Depending on your needs, there are certain like high level toggles that can fairly immediately help with that. Things like turning on unify true would help, turning on reuse would help, avoiding duplications. So that's all under the theme of duplications. If it's even true that you might have 0 duplicates and still too many things. And if you're in that, if that's your problem, it's probably, I would say, probably the thing you could complain about Spack is that the things that it's installing are things that you already have on your system. I mean, otherwise, if they don't exist on your system, I'm not sure too much about how Spack could help. I mean, I have one final suggestion for that, but like externals would then be my next suggestion. And then finally, there is a pretty high level toggle for a lot of CMake based packages where you can control I think it's called build type. And I'm actually having trouble remembering where it was or what we used to have a default called rel with deb info, which is like debug information. And for some CMake builds, that could produce like maybe an order of magnitude more space, like that could take up more space. And then a lot of people were saying like, why don't you set the default to release for CMake packages? And I can't remember whether we've changed that, but well, either way, if you have it set, that would produce, if you have build type equals rel with debug info, or if that's the default, then I think that might be a final toggle